High-rise long-span steel structure with semi-rigid connection using bracing system. Abstract: generally, in steel structure the connection between beam and column are designed as moment connection and pinned connection, but in actual condition the structure behaves between these two conditions, resulted into semi-rigid condition which is intermediate stage between rigid and pinned joints. Effect of semi-rigid connection on multi-story multi-bay frame is accomplished in this paper. The present study introduces the effect of static and dynamic loading on high-rise steel structure of G+15 story with 4m, 6m, and 8m 3-bay span length. Structure is analyzed under two different condition of partial release of semi-rigid connections which is derived by fixity factor of values 0.5 and 0.75, as per AISC, in this study. The analysis is done commercially available software-STAAD.Pro. From the nonlinear analysis, the story displacement and story drift are obtained. The overall performance of the structure from the analysis: semi-rigid joints display more story displacement and story drift compared to rigid joints. To overcome the results, bracing system is introduced at different location of periphery of structure. These brace frame structure consist of X bracing and diagonal bracing. Again, comparative analysis is to be performed in STAAD.Pro on these 3-bay span lengths. It is found that braced semi-rigid frame structure perform quite well as compared to unbraced frame structure. Keywords: multi-story multi-bay frame, semi-rigid connections, fixity factor, brace frame. 1. Introduction. Steel structures are made up of different elements like beams, columns, bracings, flooring and roofing systems. In every structure beam-to-column connections are important and inherent component of steel frame structure, and their behavior influence the global performance of the structure under various loadings. Generally, connections are characterized in two types: 1. Moment connections and 2. Pinned connections. Besides that, in actual practice steel connections are not providing ideal rigid or pinned, but behavior of connections fall between these two condition called as semi-rigid connections, which basically based on their stiffness criteria. Basically, connections are classified by their strength as well as their ductility, where ductility is a description of the rotation capacity, i.e. rotational stiffness. As per AISC, American Institute of Steel Construction, fixity factor is derived to evaluate rotational stiffness of member of the structure, which is conventional practice, but it gives approximate value of partial releases in the structure as well as their behavior is also influenced on the rotational stiffness of the member. 2. Literature review. Nandisha and Kashinath, 2017, investigated the analysis of multi-story steel space frame by varying fixity factor and found the capacity of strength of joints and to perform linear static of semi-rigid connection steel frame using response spectrum method. Considering 0 fixity F factor for pinned or hinged joints and 1 for rigid joints, and the variation of bending moment, shear force with varying fixity factor was found out. Nihan Dogramak Aksoiler, Hussam Mahmood, 2011, have studied the moment-resisting frame with semi-rigid connections and prepared 26 sample model frames were evaluated with pushover and dynamic analysis under 25 strong ground motion records. Main outcome of investigation was overall top story displacement of structure with semi-rigid structure are smaller than rigid frame structure. Peng Deng, Yaijuan, Xiaotong Shang, 2015, had studied comparison of eccentric inclined braced steel frame with semi-rigid connection and simple steel frame with semi-rigid connections. Based on seismic performance, the energy dissipation capacity was found out in terms of lateral stability and stiffness of the structure. Mohammad Razavi, Ali Abul Mali, 2014, came up with new concept of hybrid steel frame system, as it contains the mixture of full rigid and semi-rigid steel connections used in 20-story steel structure. They assign the semi-rigid connections as replacement of rigid connections at different location of structure. By performing the parametric study of seismic analysis, they correlate the cyclic behavior of hybrid frame structure in terms of story drift and life safety. Anuraji, Hemlataji, 2018, Their effort was made to find out actual behavior of rigid and semi-rigid connection by performing nonlinear static analysis on G+5 story structure in SAP 2000. From analysis, story drift value and performance points were obtained. 3. Methodology for analysis. There are many methods to find out capacity of semi-rigid connections, but in this paper needs to estimate rotational stiffness of member of structure. Main aim to analyze the performance of high-rise, G+15 story, long-span steel structure with semi-rigid connections using bracing system. It is proposed to carry out the analysis of multi-story multi-bay frame, contains 4M, 6M and 8M bay length, considering the ideal rigid and semi-rigid conditions using STAAD.Pro and evaluate the effect of height, span, fixity factor, rotational stiffness. Apart from this analysis, in this research widely investigated the comparative analysis of semi-rigid connection with or without bracing system. As per convenience, X bracing and diagonal bracing are used at different location of periphery of structure. The primary aim of this study to compare the two types of partial release condition as per fixity factor equation. Fixity factor considered 0 for ideally pinned conditions and 1 fixity for rigid conditions in the analysis of frame. As per past experiences and researches, the most favorable results are obtained for the range of 0.5 to 0.7 fixity factor. Present study incorporates the analysis of steel frame structure using fixity factors 0.5 and 0.75. i.e. 50% partial release structure and 25% partial release in structure. In end fixity factor, Ri is written as Ri, rotational spring stiffness of connections. Ei/L, flexural stiffness of elements. Using above equation, there are 63 models prepared as per different conditions of fixity factor, 0.5 and 0.75, bay lengths and bracing system. The flowchart of methodology of analysis and classification of models are mentioned below. Z. As per different bay length 4M, 6M and 8M and also different bracing system, total no of models 63. 4. Analysis. All primary data are mentioned in Table 1 and 2. Apart from this, section properties and loading conditions are given in STAAD.Pro. The partial releases are providing at start and end of the beam members, which is mentioned below Fig 1. Figure 1, using partial release in beam section for semi-rigidity. Mainly two type of bracing system, X and diagonal, are provided on different location of periphery of structure. The detailed rendering view of structures are presented in Fig 2 and 3. 5. Parameters for earthquake and wind analysis. Table 4. Seismic analysis data. As per IS 1893-2016, Part I. Using response spectrotron analysis. Also, measure the effect of bracing system, X and diagonal bracing, on lateral stability of structure. The results comparison of lateral displacement between rigid connection and semi-rigid connection for 3 bay lengths are shown in Fig 4 and 5. 7. Conclusion. From the overall analysis, it has been observed that lateral displacement in semi-rigid connection is more than rigid connections as well as increasing in bay length. Reduction in results with increasing the flexibility of connection about fixity factor 0.75 as compared to fixity factor 0.5. As span increase, the more lateral displacement observed. To overcome this effect, the bracing system is used to improve the lateral stability of structure. The analysis results of X-braced frame have indicated more lateral stability than diagonal braced frame. In the overall seismic analysis of high-rise structure, corner and full perimeter braced frame enhanced to give least lateral displacement and drift comparing with middle braced frame from above figures.